1:45 to 3:45 in this week. Okay, so it's assigned, so there might be no conflict schedule with the other final exam. So also do not ask any makeup exam for the final. I already announced the final exam week schedule. So please try to test on time during the final exam. Also, before 1 week before the final exam, actually I planned the 2 exercises, but I'd like to combine into one on April 29th. So we will have 1 exercise left, and on May 1st, I'd like to have a demo for your project. A and B. I will announce the detailed schedule time slot for your demonstration. I will set up the such a schedule with my GA, the young one. Okay. And next week, some of you guys are taking the engineering 400. The engineering 400 is the seminar course, 1 credit-hour seminar course. I am coordinating that course. Next week we have an invited speaker from Purdue University, whose name is the Professor Walid Arif. So his expertise on databases. So I'd like to personally invite him to the classroom. So he will provide a very light talk. It's not formal presentation. He's not going to present the very specific details of the research. Instead, he will have a light talk regarding to the database and research. So not the full time, so probably 30 to 35 minute talk during the class. So do not miss that opportunity in the classroom. Okay. Any question regarding to the schedule? As I said, if you, even though you already submit project A, but couldn't complete it, try to complete and resubmit, then inform to me and GA. So usually I accept the resubmission, but if you do not submit anything, definitely you will get a late penalty. Okay? Any question regarding to the project and final exam schedule? Then pretty much you will check. Some of you guys are graduating, so you need the final grade urgently. So I try to my best. Probably right after final exam, so it's a Thursday. So your final grade will be available. Probably the Friday may not, so half and half. But at least the Monday. The next week. Okay, so before I post the final grade, I will give a chance to check your final exam only. Okay, before that you need to check all your grade, including homework, quiz, project, and midterm before final exam. Okay, then after final exam, just before I post your final grade, I will give you a chance to review your final exam only. Okay. Any question? Okay, so we will continue our lecture for the functional dependency and normalization. Then followed by today we will briefly talk about the database tuning. So why do we need the normalization? So we are not sure whether our initial draft version of our modeling is good enough in terms of performance, in terms of redundancy. We are not sure. So we need certain guideline to check whether our database model for relational database, relational model is good enough. Is there any way to measure the goodness of the database model? At the time we can measure such a goodness based on what? Functional dependencies. So we talk about the first informal guideline. So informal guideline means it's just a description of such a goodness measure. First guideline is one table, one entity, include one meaning. How can we make such a goodness measure? So one meaning, once in one table, one semantic in one table. How can we define the formally such a thing? So at that time we can use the functional dependency. Functional dependency means x determine y. What is x? It's a set of attributes determine set of attributes. Okay? So at that time we can find a bunch of huge amount of actually the functional dependencies. Among them we are interested in the minimal functional dependency. So minimal set of the attribute determine the other attribute. Usually x is what? Key attribute. We regard such a set of attributes on left hand side. X as what? Prime attribute. All the other attributes are non-prime attribute. In other words, if we know the prime attribute, key attribute, primary key, candidate key attribute, we can determine the others. Okay? And to identify the other attribute, vice versa, we need to know what is a prime attribute, what is a key attribute, what is a candidate attribute. So we will use such a minimal functional dependency to normalize our database design. Specifically, this is the relational database model. So some of students confused after finish the discourse. I'd like to normalize object-oriented database. That doesn't make sense. This normalization means only for relational database model, because relational database model itself is not very flexible. Okay? It's a very, very restricted database model. Okay? Because of that, we need to consider such a normalization process in order to reduce the redundant information. In case we have duplicate data, performance will be degraded. Also, very hard to manage the data. We cannot guarantee consistency of our data, which means when I search Professor Lee, there might be a bunch of other professors. That is called anomaly situation. Insert, delete, update anomalies. Okay, so we have unnormalized form, which means we collect all information, make the attribute, bunch of whatever you want. Okay, so we can make the unnormalization form. There might be huge amount of duplicate data in this database model. Okay, then we'd like to apply some constraint. Okay, and more constraint. This is called normalization process. So in order to make the first normalization form, what is the first normalization form? First, we focus on each attribute. Each attribute should not be composite attribute, not multi-value, not nested. Some of you guys already realize why we need to consider such a first normalization form in relational model. Relational model allow only one value in one attribute. Because of that, we cannot consider object concept in our relational model. Because of that, we need to separate all value for the column. Okay? In object-oriented concept, we can even consider the student itself as the column. Yes, that's true. Because we define one column as the object, but not in relational model. So that is the first normal form. But this is only attribute. We can focus on the attribute. Then, second normal form is no partial dependency. Partial dependency means, so we have sample attribute A, B, C, D, and E. This sample table. Okay, so let's say A and B is the prime attribute key, primary key. Let's say A and B is the primary key. So in this model, each A, B, C, D, and E satisfied with the first normalization form. There is no multi-value, there is no composite, there is no nested. So it's the first normal form. So Then next, check whether this is the second normal form. Second normal form is there is no partial dependency. What is the partial dependency? To have one meaning in this sample table, A, B determine C, A, B determine D, A, B determine E. This is one meaning, right? However, if there exists A determines C, this is called partial dependency. C determined by part of prime attribute. So A and B is different from A. So which means it's a different meaning that violates first guideline, informal guideline also. So this is called partial dependency. So if there is no partial dependency, this one satisfied with second normal form. We can say this is in the second normal. What if we identify such a partial dependency? The only solution to make the normalization is segment. Always a segment. Decompose. Divide. Okay? So we can take out this part. So A determine B. So which means we can make one table for this. A determine B. Then there is no partial dependency on A determines C. Then you can remove C here. Okay? So this one satisfied with second normal form. One question. If a table has one prime attribute, which means primary key is a single column, single attribute. Is it second normal form or not? Or we don't know. It's automatically second normal. Why? What is a partial of A? There is no partial. A is a single attribute. So A determines B, A determines C. So there is no partial like this. Can we make the part of attribute A? No. So always this is a whole dependence. So once you identify the single attribute, single column primary key, single column prime attribute, it's automatically second normal form. Yes?
What if there is a semantically partial relation in the relation? Like if was
What does that mean semantically? So that is the reason I really generalize. Okay? Even though A means, for example, name. Okay, name as first name, last name. But we already consider name as one value. Why? Because it's one first normal form. It's already in the first normal form, which means it's a atomic value. We cannot divide. Which means it's one semantically, one meaning. Okay? Even though you believe we can separate the name as first name, last name, but if even before that, we regard that this attribute is atomic. We cannot divide into two. So which means in case of single attribute, primary key is automatically second normal form. So no partial dependence. So example is like this. This one. So social security number plus P number determine hours. Social security number P number determine E name. Social security number P number determine P name and P location. So this, what is a prime attribute? SSN P number. Determine the other. Is there any partial dependency? Yes, because social security number determine E name. Also, P number determine P name and P location. There are two more partial dependency. In other words, this table, this model has how many different meanings? Three. one is FD1, functional dependency 1, that represent works on how many hours each the employee works for the specific project. This one represent employee table. This one represent project table. Can we make the second normal form? Yes. How? The only solution is decompose. That's normalization. Okay? They take out the SSN, determine E name, and P number determine P name and P location. So we don't need in original table. So there are 3 tables. It's a normalized. Okay? And apply. Consider the informal guideline. One table, each table has 1 meaning. Okay? And no update, no insert, no delete anomaly which happen in this table. And also less none than this one. Okay? So actually the informal guideline and the formal normalization process are almost identical, but different approach. Okay? So that is the second normal form. The next one is, even though there is no partial dependency, whole dependency, sometimes you can find A, B determine C, and C determine D. So you have 2 functional dependency, FD1, FD2. See it? Second normal form or not? Second normal form or not? Can you find any partial dependency? Partial means part of prime attribute. What about the FD2? C is not prime attribute, so it doesn't matter. Okay? So A, B determine C, C determine E. So this functional dependency, A, B determine B, C, and C determine D. A, B. This is called transitive. Transitive is not partial dependency, so it's in the second normal form. However, if you take a look at this part, this is looks like 1 meaning. Okay? So in third normal form does not allow such a transitive because it's another meaning. Okay? So how can we make this one to the third normal form? The only solution in normalization is decomposition. Take out this part. C determine D. So this is another sample table. Then we don't need C over here. Because D, David, is determined by C. Okay? So this is for third normal form. Third normal form does not allow what? Transitive. Okay? So let's take a look at the example here. So social security number determine D manager social security number. Yes, in the table. However, social security number, using the social security number, you can actually identify the department number of that employee. And using that department number, you can identify D manager social security number. Okay? After this. SSN is a prime attribute, and this is the D number, DNO, and D manager SSN. SSN determines department number determines D manager social security number. As you can see, D number determines D manager social security number is actually what? Department information. So for example, when you have a data 111, DNO 1 and D manager social security number is 999. 222 1999. These are redundant information. Right? We don't have to keep multiple times. So to address that, in other words, to make it normalized, third normalization form, we can take out this part. DNO determine B manager, social security number, and this. This is the third normalization form. Third normalization form does not allow such a transitive. So this is an example. Social security number actually determine all of this, but you can identify D number determine D name, D number determine D manager, social security number. Is it first normal form? First. Yes or no?
No.
Yes.
Yes.
No? Yes? It's the first normal form. First normal form is just check each attribute. It's autonomy. There's no composite, no multi-value, no nested. So it's the first normal form. What about second normal form? You don't have to worry about in case single attribute primary. Automatically, second normal form. You cannot find any partial of a single attribute. So it's a second normal form. Third normal form? No, because of this transitive functional dependencies. Okay? So, how to make third normal form? The only solution is decomposition. Separate. So we can take out D number, D name, D manager, social security number, and social security number determine the D name, D date, address, D number. Okay? This is the third number. So we can make any unnormalization form. Actually, some of you guys already realize using this normalization process, you can do design, model. In other words, without applying logical modeling, physical modeling, conceptual modeling, using the ER modeling and the physical modeling, you don't have to apply such a long process. Instead, we can collect all attributes and information, then apply normalization process. And actually we can make the database design. However, the reason why we do not directly apply this one at first is how many attributes in unnormalization form. Sometimes more than 10,000 attributes. It's very, very hard to identify all functional dependency. Sometimes more than 10,000 functional dependency you can find. Okay? So first, initially apply ER model for conceptual modeling. Okay, then transfer mapping into the relational model. Then apply the normalization process whether you have such a first normal form, second normal form. Third normal form is actually the basic. In other words, as I said, if you believe yourself is a normal person, even though you do not have the background in database design, database modeling, computer science, no, you don't have to worry about it. If you believe you are just normal, actually you can do up to third normalization form automatically, intuitively. Okay? That is the reason many of the database model, database design are performed by non-computer science person. If you join the big project like the mega size project or $1 billion project, actually most of database design will be done by business guys from CPA or some consulting company because they know the money flow. That is the most important one. How the money is going, currency. Okay? So that is most, or the policy, law, or some regulation. So that is the reason nowadays the computer science knowledge, yes, you need such a knowledge, but also you need business. So technical management is a good example. Okay, business process engineering or business intelligence analysis. So even business school offer the computer application or IT, the concentration. Okay, so that is the reason. So you already did. before you take this course, many of you guys actually did the third normalization form for your simple database in your project. Okay? So that is the third normalization form. So third normalization form is a single attribute, atomic attribute, no partial dependency, and no transitive. Most, I think the 90%, more than 90% of the database in our world actually third normalization form. That's pretty much enough. But the other less than 10% actually require higher level, details level of the normalization form. Also, that's more critical for the system performance. So we will see the rest of them. So this slide shows the very simple summary of the normalization. So first normalization form, all attribute depends on the key. Does it make sense? Because we cannot divide each attribute into two, which means any attribute will be determined by the key, right? And second normal form, whole key dependence, because no partial. No partial means whole key dependency. And third normal form, what does it mean? Transitive. Transitive is like this: A, B, C, and A is the prime attribute. But this one determined by non-prime attribute, right? So nothing but the key, prime attribute. Only primary key determine the other non-prime attribute. Okay. Actually, there's the A, B determine C. This is the first normal form. What about the second normal form? Is this second normal form or not? Yes. There's only one functional dependency. So, second normal form, right? You don't have any partial here. What about the third normal form? There's no transitive, so it's in the third normal form. So, what if I add this one? It's not in third normal form, we need to take out this. What about this one? C determine B. So we have, this one, A, B determine C, this is a prime attribute, and C determine B. Is this the transitive one? Transitive? No. It's not transitive. It looks like a transitive, but A and B determine C. It's a prime attribute. But C determine B. Go back to original one. This is kind of origin, starting point. Okay? That determines C, but C determine B. Prime attribute. It's not the new one. Okay? This is actually the same meaning. A determine B, determine A. However, in this case, only part of the key. So we do not consider this one as the transitive because it's going back to original. Okay? So this is in the third normal form. However, after EF code and I forgot the Boyce. After Boyce, his colleague at the time, they realized this, in case this kind of the functional dependency, that may cause some redundant problem, even though that is not transitive. So they said this is called pseudo-transitive. It's not real transitive, but it's a pseudo, fake transitive that may cause the normalization problem. So we need to address that problem. How to address that problem? We can remove, take out, segment, this one. Okay? So that is called BCNF, Boyce-Codd normalization. normalization form. Boyce-Codd normalization form is a subset of third normalization form. Sometimes it's called strong, the third normalization form. Most of the system is up to BCNF actually. But BCNF is not easy to intuitively understand. So think about prime attribute determine the other. But in case the other non-prime attribute determine prime attribute, it's going backward, right? So because they do not define the new attribute, C determine D, no, not like that. So there's no problem in terms of the third normalization form. However, if we take a look at the data itself, it's redundant. So we are going to take. However, there is no straightforward way to take out this pseudo-transitive. We will take a look at the example. First, we will see how to understand. This is the example of the import, export, something like that. In this, the initial design, property ID is the primary key. Okay? And also, there is the candidate key, country name plus lot number. This is the candidate key. Okay? You know what is the candidate key? Candidate key is almost the same as the primary key. We identified two keys. Okay? For example, employee ID and social security number. Two keys. But how many primary keys? One. So we need to select one of them that is the property ID. Then the other will be candidate key. In this case, in this example, what is prime attribute? Prime attribute. Key attribute. Property ID, number, plus country underbar name, plus lot number. Because this is anyway key attribute, even though that is candidate key. Okay? It's not fair if we ignore this one. Because the candidate key is almost the same as primary key, but it's not selected. So we consider even candidate key attribute as the prime attribute. And the other non-prime attribute include area, price, and tax rate. In this example, is it the first normal form? First normal form or not? Yes. Yes. No problem. We cannot find any problem each attribute. It's an atomic attribute. What about second normal form? Can we identify any partial key?
Yes.
What is a partial key? Not whole key. So in case the single attribute primary key is automatically second normal form, but not true in this case. Why? You need to consider candidate key also. Candidate key is the same as the primary key in normalization process. Actually, in real database, candidate key is also very, very important. Even usually, you need to create the index for candidate key because it's a unique. Anyway, so we need to check. This is a single attribute, so no problem from this one, functionality. However, we need to check this one also. So country name plus lot number determine property ID, area, price, and tax rate is okay. However, we have functional dependencies 3. Country name determine tax rate. Because of that, this is not in second normal form. How can we make this second normal form? Just take out that part. Which one? Functional dependency 3. Not here. Here. So country name determine tax rate. That makes sense. Each country has their own tax, custom tax, right? And what about the other? Property ID determine the other. Country name plus lot number determine this. And area determine price. No problem. Why? Area is not prime attribute. Okay? So this is in the second normal form. What about third normal form? Is it in the third normal form?
No, it's not.
No, because of this. A determine B, B determine C. So this may form the different meaning. Let's take a look. Area determine price. Each area has their own price, like the Europe or something like that. May I guess such a thing. How can make it third normal form? Just decompose, right? So there's it. Here. So we can take off area determine price. So this is in the third normal form. Okay. So first normal form, second normal form, third normal form. Finally, we can have 1, 2, 3, 4 tables. That forms third normal form. Okay. What about this one? We identify one more functional dependency, that is area determine country name. For example, European area. Europe may have several countries, right? North America may have several countries. So that means area determine country name. Is this in the third normal form? Yes, still third normal form. This one is not considered as the triangle. However, if we consider BCNF, Boyce-Codd normalization for more strong constraint condition, so we will consider this one as the transitive in terms of BCNF. Because country name, land number determine area, area determine part of prime attribute. Okay, then how can we solve the problem? We need to decompose, normalize. But there are different ways to normalize. Why? Let's take a look at this even. Actually, this is a teaching table. It's an initial draft. I don't think not many students can model such a way, but somebody may design like this way. Student, course, instructor. So student and course determine instructor, right? That makes sense. Each student takes the course that determine instructor. Then also instructor teach course. Instructor determine course. So this is BCNF case. Third normal form, but not in BCNF. We need to address that problem. However, this is cannot be intuitively take out the instructor determine course and student course. You can think about the 3 different ways where you focus on. If your database is focusing on the student information, so this database is for student, you can leave the student in both tables. Student determine course. Student is taking course and student is taught by the instructor. Similarly, if you believe this database is for course information, like the managed by registrars, you can consider course as the key. And similarly, instructor. So there are different ways. Student, course determine instructor, and instructor determine course is neither way, but it can be student, instructor, and student course. You can put the student both sides if you believe this is for the student database. Similarly, you can put the course both sides or instructor both sides. There is no general way to decompose. You need to select one of the things for BCNF. But not all cases are perfect, actually. You may have some redundant information in this case. Okay? So this is the BCNF. What about the next one? We have first normal form. We have fifth normal form. First normal form does not allow multi-value. We already discussed in in the relational database. And why fifth normal form does not allow join dependency? It's called the join dependency. So it related to the join. But we do not cover fourth and fifth and some special case. These are very, very rare cases. Okay? So in case you encounter such a problem, you can look up that one and one, the solution. So I believe we can do that. But up to BCNF is the general way to normalize the database. Okay? Any question? Yes?
Which attributes determines the averages?
Yes.
It will be given, or I will have to decide.
If you are taking exam in my course, probably I'm going to provide the functional dependencies if that is not obvious. But if obvious case, you can identify the functional dependency with the sample data, then normalize it. But in real case, it's totally your job to identify such a functional dependency. Nobody actually say this is a functional dependency. Your customer does not know what is the functional dependency. Okay? Even many of the database designers, they do not know the name of functional dependency. However, they know what that is when they model. They intuitively, based on their experience, they don't want to keep the redundant information. They want to separate that. Okay? This is the formal step, formal definition about such a normalization. I have seen the many database designers who never taken such a database course, but they can do. Even they do not know what is a BCNF, what is a course NF, but based on their experience says how to do that. Okay? So functional dependency is the same, but to identify the details of, sometimes you may not recognize whether this is a functional dependency. Later, when you launch the system, you will see the problem 1 year later. Okay? But if you have the good experience on the design, while you are designing your database, you may identify this may cause the BCNF problem, so you can say. That's the difference. But it's very hard how to identify the functional dependencies. There is a formal way, algorithm. Even nobody applies such an algorithm. That is just nothing but mathematical way, proof of the minimal functional dependency. Most of cases is based on the experience, okay, and practice. Okay. But in the exam, if non-obvious case, I probably provide a functional dependency. If obvious, then I do not. Okay. Yes. Question? No. Okay. So that's good question, which means you need to practice. So I already upload the 5 examples on the class website. I do not bring the hard copy of that, so it's the next homework. You don't have to submit the answer. I'm going to post the answer next week, but meanwhile, please practice by yourself. Definitely, I will use that example, that homework for the final exam. Okay? If you cannot understand the entire normalization process to prepare even the final exam, memorize. Okay? I slightly changed the name only. I did the same thing last few years. Average point is around 50%. Really, please practice. I already posted post in the class website, download or print and practice by yourself. Each question has different formats. Sometimes it looks like a weird example, like the invoice. Okay, sometimes I provide something very nice table style. Okay, initial the model. So with the sample sometimes I provide a functional dependency. Why don't you practice? I will post the key answer solution next week. Meanwhile, practice by yourself. If I ask you to submit it, some of you you guys get the answer key from your friend who took the last semester. It's a waste of your time. Okay? That's the reason I do not ask you. I don't want you waste your time to copy, and I don't want waste my time to grade copied one. So it's for your practice. Okay? Definitely I'm going to use that homework for final exam. So most important thing, understanding the algorithm itself is not very complicated. It's very simple. That is the reason such a relational model, RDBMS, is still most popular DBMS. Even designing, think about what is the new, the object-oriented database. There exists the object-oriented database management system with the object-oriented model. It's not popular. One of the reasons is the current vendor, including Oracle, IBM, Microsoft, they don't want to change their product. That's the first reason. Second reason is still object-oriented concept and object-oriented database is a little bit complicated for those who do not have background in computer science. I believe you guys know everything about the object-oriented concept, inheritance, whatever, but most of this no. Especially for consultants, they do not know. But relational model and normalization, as you can see, it's very simple, straightforward. You can just follow the step by step. And very powerful, it works very well for terabyte size data, even up to the petabyte size database. What about the big data system that are currently hot issues? It deals with the bigger than petabyte, exabyte, huge amount of data. Their modeling is more complicated than this because it does not have even schema. Yeah. Right? Which means, how can, anyway, you need to design a model to put your data, big data, into the NoSQL database like the Cassandra, MongoDB, whatever. But it depends on the database, not like the standard the design. So that is another reason here, relational database model works very well. Okay, everybody likes this. Okay, so that is the normalization. Next class, I will take the 1 or 2 question from the homework. Okay, you don't have to submit the answer, but you can bring your question. If you have any question, I will be prepared for your question regarding to the normalization. Okay. Practical database design and tuning. Why do we need tuning process? Why do we need the practical database? First, what is the practical database design? What is not practical database design? In other words, it's a logical database design. That's what we have done so far. Okay? We actually learn how to design and how to create the database, but we don't know what's going on inside our database. Can you remember this one? It's the GUI schema architecture. Same standard database architecture. We focus on mainly conceptual design. Employee, department, they have such a thing. And also using SQL language, we can create this one. Using what? Relational database management system. In our class, we use Oracle database, Infobase, DB2, SQL Server. Okay? And also external view is nothing but view. So we can use the SQL. So we cover this part. This is called conceptual database design, logical database design. But we don't know how employee table is stored in our physical hard disk drive. Who is in charge of that? Who is in charge or who actually stored such a data? Admin? I had been working 7 years. I never assigned the specific sector number or cylinder number. I don't know. DBMS, no, such a internal structure, internal view of the database. Each DBMS has different. Okay, so there's no way to control such a thing unless you create the database management system by yourself, or you can hand it inside the code. But have you ever decoded C compiler? Have you ever decoded the compiler using the Visual Studio? No. We try to get the benefit of abstraction, right? Just the command name, then the option parent value, then we can use it. Same thing. So we do not worry about the internal data structure. We don't have to worry about how the variable character is assigned in the hard disk drive. Okay? But we learned briefly about such an internal structure like the span, blocking, whatever. Okay? But that's just conceptual level, very high level. So DBMS vendor, DBMS system, application is in charge of such an internal view, and